Alright guys, welcome to this page of the notes, and I know, whoa, look at that ugly thing. Okay, there's really no way to sugarcoat it. They're tricky. There's a lot of places to kind of get hung up and make simple mistakes. So what you want to do is work through these couple example problems with me. I think I've got 3 or 4 of them. All right, sort of learn the process for how we go ahead about doing problems that they're just ugly. But figure out the process for doing it, and then practice on your own. If you're taking this class with me, there'll be a couple of them in the homework where you'll get a chance to sort of practice the skill that we're going to learn here. What I'm going to ask you to do, right, is to simplify these complex rational expressions. Here's why they're so tricky. Please notice fractions that are being subtracted in the top, fractions that are being added in the denominator. You're going to have to find a common denominator in the top, so I can subtract these guys, and you're going to need to find a common denominator in the bottom, so that you can add these guys. Now, I will keep these as simple as I can, but there's really no two ways about it. They do get a little complicated. Again, we'll work our way through them. You'll catch on quick. We'll see how these go. All right, so I need, right, because I am subtracting fractions in the top, I must have a common denominator. But it's really, really easy. The LCM of x and y is xy, right? That's the LCM. The factor is x, the factor is y. Put them together, your LCM is xy. So, I need an xy here. Now that means I multiply top and bottom by y. I need an xy here. That means I multiply top and bottom by x. So, again, like I said, I'll keep them as simple as I can, but it's still going to be quite a bit of work. All right, so anyway, here we go. We've got 1 over x, and I'm going to multiply top and bottom by y over y. Again, x times y is going to be my LCM, minus 1 over y, which I'll need to multiply top and bottom by x, again, so that I get that xy. Now I'll have a common denominator of xy, and I can subtract these fractions. In the bottom, well, this 1 can be thought of as 1 over 1. Well, what is the LCM of 1 and x? Well, 1 is prime, x is just an x, 1 times x is x. So the LCM is x. The LCM is x. Well, this guy already has an x, so I don't have to do anything to it. Right? I don't have to do anything to this guy. He already has my LCM, which is x. But this guy needs an x. So I'll need to multiply top and bottom by x so that I have a common denominator of x. So 1 over 1 times x over x plus 1 over x. And again, I don't need to multiply this guy by anybody because the LCM is x, and it already has an x down there. All right, I have now, right, figured out how to get my LCM, so let's go ahead and multiply these fractions together and see what shakes out. Okay. Well, 1 times y, that's y. X times y, that's xy. Minus 1 times x, well, that's x. Y times x, well, that's xy. And as I hoped, right, common denominator. It's my LCM, xy. In the bottom, 1 times x is x, 1 times x is x. So I wind up with x over x plus 1 over x. Now that I have my common denominators, xy, xy, x, and x, I can subtract the fractions in the top. I can add the fractions in the denominator. So let's do that. I'm going to have y minus x over my common denominator, which is xy, all divided by x plus 1, all over x. Okay, so we've already done quite a bit of work here just to be able to subtract the fractions in the numerator and add the fractions in the denominator. But that gets me to yet another complex fraction, which we looked at back in Chapter 8, Section 1. So we just did all that work of adding and subtracting rational expressions to simply get us to a problem where we have to simplify a rational expression like we saw back in Section 1. So there's still more to do. This is a complex fraction where I have a fraction in the numerator, a fraction in the denominator. Since it's division, we recognize it as keep it, change it, flip it. Keep the top, multiply by the reciprocal of the bottom. So let me rewrite it. And I'll do it right here so you guys can see this. It's y minus x over xy, right? That's my numerator. Change the division to multiplication, and then flip, get the reciprocal of the bottom. X over x plus 1. Okay, so now I'm going to work on simplifying this. And again, if you remember back in the previous section, Section 1, we want to start by cross-canceling if there is any. And there is x and x. Those will cancel each other out. That's it. That's the only cross-canceling I have. It becomes a 1 and a 1. So here's what's left. I have y minus x over y times 1 over x plus 1. All right, multiply these guys together. X minus y times 1. No, that's just a y minus x. I apologize. I think I said x minus y. It's not. It's a y minus x. Y minus x times 1. Just a y minus x. And then this guy. Well, y times x plus 1 is y times the quantity x plus 1. There's nothing else you can do to it. And that is going to be simplified form. Again, though, it is a rational expression. You'll need to restrict the domain. Fortunately, the x and the y are multiplied, so it's really simple. Y cannot be 0, x cannot be 0. And now that you've restricted your domain, you have your simplified rational expression, and you've told me what values of y and what values of x are not allowed, so that I don't wind up with 0 in the denominator. I know, it's a lot of work. There's a ton of stuff going on in here. But again, as we do a couple more of these, you'll begin to see a pattern in the way they work. First, you'll have to add or subtract the fractions in the top, add or subtract the fractions in the bottom. Once you do that, you'll then wind up with a complex fraction, which you'll need to do keep it, change it, flip it to then simplify down. It's that same process over and over and over again, even though I'm changing the problem. So head on over to the next page of the notes. We'll try a couple of more of these together. I can't wait to look at them with you. I'll meet you there.